cost of updating an electrical service and completing a rewiring job to bring it up to code can vary significantly based on several factors. These factors include the size of the service in the home, the number of rooms and electrical outlets requiring work, the complexity of the rewiring required, and the prevailing materials and labor costs in your specific area. As a general guideline, one can anticipate a cost range of approximately $10,000 to $15,000 for a complete service update and rewiring project. However, remember that this is a broad estimate and actual costs may deviate based on the specifics of a particular situation. Hiring a licensed electrician is crucial. It is imperative to engage a qualified and licensed electrician to undertake this kind of work. This ensures that the job is executed safely and adheres to all applicable electrical codes and regulations. Employing a licensed professional provides assurance that the work will be performed to a high standard of safety and compliance. Obtaining multiple quotes is also very important. It is prudent to obtain bids from several electricians to enable a comparison of costs and the services offered by each. This comparative approach allows for informed decision-making, ensuring that the chosen electrician provides the best value for the required work. Discussing needs thoroughly is also crucial. Clearly articulating specific requirements, such as the desired number of outlets and the necessary level of electrical capacity, is paramount. A comprehensive discussion of needs ensures that the electrician fully comprehends the project scope and can tailor the work accordingly. Considering energy efficiency is also very important. Choosing energy-efficient materials and fixtures can contribute to long-term cost savings on electricity bills. Energy-efficient solutions not only benefit the environment but also provide economic advantages over time. Inquiring about permits is a must. Ascertaining whether any permits are mandated for the electrical work in the specific area is essential. Confirming that the electrician obtains these permits ensures compliance with local regulations and avoids potential legal issues down the line. Preparing for disruption is also required. Rewiring endeavors can introduce some level of inconvenience and noise. Advanced planning and arrangements can mitigate these disruptions, ensuring a smoother process. Checking references is also a great idea. Requesting references from previous clients allows for an assessment of the electrician's reliability and workmanship. Feedback from past customers offers valuable insights into the electrician's professional conduct and the quality of their work. Consider a surge protector for safety. Installing a whole house surge protector can safeguard appliances and electronics from power surges. This protective measure can prevent costly damage and extend the lifespan of electronic devices. Adding smoke and carbon monoxide detectors is very important as well. Ensuring that the home is equipped with smoke and carbon monoxide detectors in all mandated areas is a critical safety measure. These detectors provide early warning of potential hazards, protecting occupants from fire and carbon monoxide poisoning. When updating an electrical service, consider these important factors. Firstly, the amperage of the new service is a primary consideration. Determine the appropriate amperage based on the current and future electrical demands of the building. Common service sizes include 100 amps, 200 amps, and 400 amps. The selection should align with the anticipated load. Secondly, the panel size and capacity are important to address. Select an electrical panel with sufficient spaces for circuit breakers to accommodate existing circuits and future expansion. Ensure the panel's amperage rating matches the service amperage. Thirdly, the service entrance cable is important. Choose the correct gauge and type of service entrance cable to handle the amperage load safely. The cable must comply with local electrical codes and be suitable for the installation environment. Fourthly, the grounding system should be considered. Implement a proper grounding system to protect against electrical shock and ensure the safe operation of electrical equipment. This includes grounding electrodes, grounding wires, and bonding connections. Fifthly, the overcurrent protection should be considered. Install appropriate circuit breakers or fuses to protect each circuit from overloads and short circuits. The overcurrent protection devices should be correctly sized for the ampacity of the branch circuit wiring. Sixthly, the location of the service equipment is important. Determine the optimal location for the service panel and meter. Consider accessibility, environmental conditions, and compliance with local codes. Seventhly, the bonding and grounding of metal components should be considered. Bond all metal components, such as pipes and enclosures, to the grounding system to create a low impedance path for fault currents. Eighthly, the surge protection should be thought about. Install a surge protective device at the service entrance to protect against voltage surges caused by lightning or other events. Ninthly, the labeling and documentation is needed. Clearly label all circuit breakers and provide accurate documentation of the electrical system. This helps with troubleshooting and future modifications. Tenthly, the compliance with codes and standards is a must. Ensure all work complies with the National Electrical Code, or NEC, and local electrical codes. Obtain necessary permits and inspections to verify compliance. During a whole house rewire, consider these points. 1. The circuit planning. Develop a detailed circuit plan that includes the location and purpose of each circuit. Consider the electrical needs of different areas of the house and allocate circuits accordingly. 2. The wiring methods. Choose appropriate wiring methods such as non-metallic sheath cable or NM cable or conduit based on the application and local codes. Ensure the wiring is properly supported and protected. 3. The conductor sizing is also important. Select the correct conductor size for each circuit based on the ampacity requirements and voltage drop considerations. Refer to NEC Table 310.15. 4. The receptacle and switch placement. Strategically place receptacles and switches to provide convenient access to electrical power and lighting controls. Consider the layout of furniture and appliances when determining locations. 5. The lighting design. Plan the lighting design to provide adequate illumination for various activities. Consider energy-efficient lighting options, such as LED fixtures. 6. The grounding and bonding. Properly ground and bond all electrical boxes, fixtures, and appliances to the grounding system. This helps prevent electrical shock and ensures the safe operation of electrical equipment. 7. The arc fault circuit interrupters, or size. Install a size to protect circuits that serve bedrooms, living rooms, and other areas where arc faults are likely to occur. A size can help prevent electrical fires. 8. The ground fault circuit interrupters, or GFCIs. Install GFCIs to protect circuits that serve bathrooms, kitchens, and outdoor areas where water is present. GFCIs can help prevent electrical shock. 9. The smoke and carbon monoxide detectors. Install smoke detectors in each bedroom, outside each sleeping area, and on each level of the house. Install carbon monoxide detectors on each level of the house and outside sleeping areas. 10. The labeling and documentation. Clearly label all circuits and provide accurate documentation of the electrical system. This helps with troubleshooting and future modifications. When estimating the cost of an electrical project, consider these items. 1. Labor costs. Estimate the labor costs based on the electrician's hourly rate and the estimated time required to complete the project. Labor costs can vary depending on the electrician's experience and skill level. 2. Material costs. Calculate the cost of all materials needed for the project, including wiring, conduit, boxes, receptacles, switches, lighting fixtures, and electrical panel components. Obtain quotes from multiple suppliers to compare prices. 3. Permit fees. Include the cost of any required permits in the estimate. Permit fees vary depending on the location and the scope of the project. 4. Inspection fees. Factor in the cost of any required inspections. Inspection fees are typically based on the size and complexity of the electrical system. 5. Equipment rental. Account for the cost of renting any specialized equipment, such as trenchers or lifts. Equipment rental costs can vary depending on the equipment and the rental duration. 6. Contingency. Add a contingency allowance to cover unexpected costs or changes to the project scope. A contingency of 10% to 15% is typically recommended. 7. Overhead and profit. Include the electrician's overhead and profit margin in the estimate. Overhead covers the electrician's business expenses, such as insurance, vehicle costs, and office expenses. Profit is the electrician's compensation for their services. 8. Taxes. Add any applicable sales taxes to the total cost of the project. 9. Discounts. Consider any discounts that may be available, such as discounts for seniors or discounts for bundling multiple services. 10. Payment terms. Clarify the payment terms with the electrician before starting the project. Common payment terms include a deposit, progress payments, and a final payment upon completion. To elaborate on permits, these are required to ensure electrical work meets safety and code compliance standards. They involve inspections by local authorities. Common electrical permits include new service installations, rewiring projects, panel upgrades, and the installation of new circuits. The process typically involves submitting an application, providing detailed plans, paying a fee, scheduling inspections, and addressing any deficiencies noted during inspections. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. Key articles include Article 210 on branch circuits, Article 220 on load calculations, Article 250 on grounding and bonding, Article 300 on wiring methods, and Article 310 on conductors for general wiring. In terms of electrical safety tips, always turn off power before working on electrical systems, use insulated tools, never overload circuits, inspect cords and plugs for damage, install and test smoke and carbon monoxide detectors, and hire a qualified electrician for complex work.